Hello everyone, this is Martha Legg and welcome to my presentation on explosive hazardous waste. The transcript of this presentation can be found in the notes section of the PowerPoint. In this presentation, I will go over the definition and history of explosive waste, pertinent regulations, explosive waste handling, storage requirements, emergency response equipment, treatment methods, disposal, and provide a conclusion. So what is explosive hazardous waste? These wastes are energetic wastes, which are also known as explosive wastes. They are wastes that have the potential to detonate, as well as bulk military propellants. Energetic wastes are designated as hazardous or RECREB because they display the characteristics of either ignitability, code D001, or reactivity, code D003, or display both characteristics. Per 40 CFR 261.23, reactive wastes are wastes that may be capable of detonation or explosion when heated or subjected to a strong initiating force, may form potentially explosive mixtures with water or react violently with water, a waste that may give off toxic gases, vapors, or fumes, or may be unstable under normal conditions, and undergoes violent change without detonating. In addition, a solid waste is reactive if it is readily capable of detonating, is readily capable of explosive decomposition, or is readily capable of a reaction at standard temperature or pressure. It is important to note that there are no test methods for reactivity, and the onus is on the generator to determine through process and waste knowledge if a waste is reactive and thus energetic. There are also explicit forbidden explosives which are listed in 49 CFR 173.54, as well as the explosives defined in 49 CFR 173.50 and 173.53, which include Division 1.1, Division 1.2, and Division 1.3 explosives. Explosives have been around for thousands of years. Dating back to the 1600s, the first known explosive used in the U.S. was black powder. This powder is a mixture of sulfur, potassium nitrate, and powdered charcoal or coal. It was used to mine and blast rocks for road construction, as well as a propellant for guns. It was used for over 1,200 years until the modern era of explosives truly began in the late 1830s. During that time, nitrocellulose was developed as a propellant and an explosive, and dynamite was created. Explosives have been used in wartime dating back to the Spanish-American War, when black powder was used as an artillery propellant. World War I saw the use of lead azide and TNT substitutes. During the time between World War I and World War II, RDX, PETN, lead stiffenate, and diethylene glycol dinitrate were developed. Flash propellants were invented, and diazodinitrophenol was also developed as an initiator. In World War II, cyclotols, which are a mixture of TNT and RDX, was created. During the war, rocket propellants, tetratol and picrotol were developed. In today's day and age, RDX, TNT, and HMX are the main types of explosives used in military applications due to performance and cost. Although the development of explosives has assisted in protecting the warfighter and the homeland and provided entertainment with fireworks, there are both life safety and environmental concerns when it comes to explosives and explosive waste. Improperly managed waste can lead to detonation and explosion, which may result in death and destroyed infrastructure, as well as toxic chemical injury, uncontrolled fires, and environmental contamination. Energetic waste falls into 5 categories: munitions, vehicle airbag propellants, fireworks, marine roadside and signal flares, and hobby rocket propellants. Munitions account for the greatest amount of explosive waste in the United States. These come in many different forms, and once declared a waste, must be handled with specific care. Currently, the Department of Defense is undergoing a large-scale demilitarization program to reduce excess, obsolete, and unserviceable munition. Waste vehicle airbag propellants are a record hazardous waste classified as explosive due to the airbag inflator that contains an igniter, booster, and gas generator. When deployed properly, the airbag consumes the propellant and removes the ignitability and reactivity hazards. However, undeployed and malfunctioning airbags are regulated. There are are exemptions found in 40 CFR 261.4J. Consumer and commercial fireworks also fall under explosive waste. Fireworks that are discarded, fail to function, not used for their intended purpose, damaged, in excess may become RCRA hazardous waste. Marine, roadside, and signal flares, as well as hobby rocket propellants fall under RCRA as well for their reactivity and ignitability characteristics. During explosives manufacturing, handling, transport, and disposal, explosives constituents and metals can be released into the environment. TNT, RDX, and HMX, which are all explosives, contaminate soils and groundwater in significant amounts. These chemicals are highly recalcitrant in nature and readily bind with soil organic fraction, causing contamination. Explosives do not degrade quickly and are very slow to degrade into the environment, which also causes contamination. According to the Handbook on the Management of Munitions Response Actions, as contaminants come into contact with soils, groundwater, and air, they may affect humans and ecological receptors through a wide variety of pathways, including, but not limited to, ingestion of groundwater, thermal exposure to soil, and various surface water pathways. The figure highlights various pathways for explosive waste contamination. In addition, TNT and RDX are potential human carcinogens, and TNT is associated with abnormal liver function and anemia. When it comes to explosive hazardous waste handling, treatment, storage, and disposal, the pertinent regulations, agencies, and rules are the Resource Conservation and Recovery Act, governed by the EPA, the Department of Hazardous Transportation Hazardous Materials Regulations, the Occupational Safety and Health Administration Department of Labor Regulations, and the Military Munitions Rule. The RCRA regulations that must be complied with for most explosive hazardous waste generators and TSDFs are 40 CFR 260 through 266, 268, 270 through 273, 279, and 280 through 282. 260 through 266 outlines a hazardous waste management system. 268 overviews land disposal restrictions. 270 through 273 overview the hazardous waste permit program. 279 is a standard for the management of used oil, which is applicable for treatment technologies. And 280 through 282 are the technical standards and corrective action requirements for owners and operators of underground storage tanks, which is also applicable for treatment technologies. Because RCRA hazardous waste is also considered Department of Transportation hazardous material, the explosive hazardous waste must be handled, prepared, and transported in accordance with the hazardous material regulations. These regulations outline hazardous materials classification, hazard communication, packaging requirements, operational rules, training and security, registration, placarding requirements for transport vehicles, and paperwork requirements such as shipping documents and written emergency instructions. Waste military munitions make up a large part of the United States explosives hazardous waste. The Military Munitions Rule of 1997 determines when military munitions on active or inactive ranges fall under RCRA Subtitle C. The regulations are outlined in 40 CFR 266 Subpart M. This rule conditionally exempts munitions that are for their intended purpose from RCRA, and the wastes are not solid waste when used for their intended purpose or when the munitions are recycled. However, unused munitions that are disposed of on range or removed from storage in a conditionally exempt magazine, declared a waste, or deteriorated are not exempt from RCRA. In addition, used munitions that are disposed of on a military range or sent off-site are not exempt, as well as open burn, open detonation of off-range explosives. Personnel that handle hazardous waste are required to be trained for their job duties. Training courses include HAZWOPER, which per 29 CFR 1910.120 includes 40-hour HAZWOPER for general site workers and 24-hour HAZWOPER for workers on site for a limited task. Hazardous communication training communicates the hazards associated with workplace chemicals to employees, as well as the routes of entry. RCRA training is site and job-specific training that reviews applicable RCRA requirements, the trainee's responsibilities, hazardous waste management procedures, and emergency procedures. Continuous on-the-job training is also a requirement. There are various personnel involved in the handling of explosive hazardous waste, and the training that they take is dependent on their job duty. For less than 90-day storage facilities, satellite accumulation workers are required to have continuous on-the-job training, hazard communication, and RCRA. Explosives ordnance disposal personnel are required to have continuous on-the-job training, hazard communication, EOD formal training, and RCRA. Hazardous waste transporters are required to have a hazardous waste transportation course, obtain a commercial driver's license, have continuous on-the-job training, hazard communication, and 24-hour HAZWOPER, as well as refresher training annually. In addition to the training requirements for explosive waste handlers, tools used for handling explosive waste must be non-spark producing. Standard operating procedures for handling, treating, and storing waste are required, and all waste handlers must have a physical fitness examination and be in a medical surveillance program. Explosive waste must be stored in explosive magazines in a secured and controlled area. These magazines must comply with the Bureau of Alcohol, Tobacco, and Firearm requirements, which are listed in 27 CFR Part 555, Subpart K, as well as 40 CFR 1910.109. These regulations state that the magazines must meet table of distance requirements. Magazines must be weather resistant, fire resistant, and permanent outdoor magazines are required to have a substantial foundation, as well as a metal skirt so personnel and wildlife cannot access the magazine from underneath. Magazines must be kept in good condition, and if they are structurally impacted or deteriorating, waste must be placed in a different magazine. Explosive hazardous waste may be stored for up to 1 year from the accumulation start date. If explosive waste is presently in a magazine, the magazine must be inspected weekly for signs of leaking, bulging, or spills of the waste. The containers that store the waste must be compatible with the waste, and containers must be in good condition. Explosive hazardous waste must also be compatible with one another in storage. Containers and magazines must be kept closed during storage and not be handled or stored in a way that can cause the container to rupture or spill. If an explosive waste has the potential to auto-ignite, it must be packed in water and then placed in an overpacked container filled with absorbent material. Explosive hazardous waste must be properly marked with the words hazardous waste, as well as a description of the waste itself, for example, a Division 1.1 sticker, or the word reactive, and have an accumulation start date. Magazines must be placarded with the waste type and the maximum net explosive weight for different hazard classes specific for that magazine must be listed in a visible location inside of the magazine. Also inside the magazine, there must be space maintained around explosive accumulation containers so that personnel can move unobstructed and any emergency response personnel are able to access the area with their equipment. Explosive hazardous waste must be 6 inches away from the sides of the magazine. An 18-inch aisle space must be maintained in earthen mags. Waste must also be kept away from sparks and open flames, for example, heat, shock, and friction. Containers with explosive hazardous waste must be located at minimum 50 feet away from the property boundary. In an emergency, there must be emergency response equipment available at the storage locations, as well as with hazardous material transport vehicles. This equipment includes instructions to personnel, telephones or two-way radios to contact first responders, fire extinguishers and fire control equipment, spill control equipment, decontamination equipment, and water. Explosive hazardous waste requires a Subpart X permit for treatment, and the most utilized method of treatment in the past has been open burn and open detonation. However, there are alternative treatment technologies. The Subpart X RCRA permit pertains to miscellaneous units. Because the units can vary so much, the units are subjected to general performance standards and not technical performance standards. In addition, owners and operators that are applying for this RCRA permit must ensure compliance with not only the general standards, but environmental performance standards. Though the more typical waste treatment and management units are outlined in 40 CFR Part 264, the miscellaneous units cover more diverse as well as emerging technologies. As with the typical waste management units, Subpart X units must prevent releases into groundwater, subsurface environment, surface water, wetlands, soil surface, and air through proper location, design, construction, operation, maintenance, and closure. Open burning and open detonation, and chemical, physical, and biological treatment units all fall under Subpart X. Per 40 CFR 265.382, open burning or open detonation of any hazardous waste is illegal. However, there is an exception for open burning and detonation of explosive hazardous waste. Open burning and open detonation are uncontrolled treatment technologies. OB is a self-sustained combustion process and entails placing the explosives waste into a burn unit with dunnage if necessary, igniting the dunnage and fuel, and burning to a temperature of, on average, 800 to 1400 degrees Fahrenheit. Open detonation physically changes the chemical makeup of the waste as the explosion passes through the material faster than the speed of sound. Open detonation involves the placement of explosive waste into the subsurface and utilizes placement of a donor charge into the subsurface with the waste explosive to initiate detonation and destroy both the donor charge and the explosive waste. It is important to note that open burning and open detonation are considered treatment and not disposal. These treatment technologies release the byproduct of treating the explosive hazardous waste directly into the environment. From the name of the technology, it can be inferred that air emissions cannot be controlled, as OBOD treatment cannot operate in an enclosed environment. There is also the potential for soil contamination through perchlorate, surface water contamination through TNT, and groundwater contamination through RDX. Though OBOD increases pollution and contamination, it is primarily the most chosen treatment technology for explosive hazardous waste, as it is considered one of the safest methodologies for life safety because it minimizes any risk due to explosive hazards, as well as the fact that OBOD allows for treatment of larger capacities of a diverse amount of explosive wastes. Though OBOD is the primary treatment technology for explosive waste due to personnel being able to destroy the waste without physically accessing the explosive itself, the extensive contamination, as well as the cleanup and remediation costs, have led scientists and engineers to research alternative treatment technologies. These technologies must be selected specifically for the site at which explosive hazardous waste will be treated due to the quantity of explosives, the type of explosive hazardous waste being treated, and the stability of the material. The technologies outlined have been tested and are capable of satisfying the life safety requirements associated with treating hazardous waste. These technologies are contained or closed and typically employ pollution controls to treat the byproducts before release. Accessing the explosives through case opening techniques such as bandsaws and removing the energetics with techniques such as dry ice blasting allows for some material recovery with the cases, once documented as safe, vice OBOD treatment destroying entire explosive bodies. The alternative treatment technologies for destroying energetics include closed detonation, thermal destruction, and chemical destruction. Closed detonation uses donor charges for detonation inside a detonation chamber, which does not allow emissions to escape and destroys the explosives. One example is a controlled detonation chamber, which utilizes munitions encased with a donor explosive and sealed chambers to detonate the munition and consume the explosives and off-gases. Thermal destruction is a closed burning or incineration technique that captures off-gases and treats by filtration and scrubbing. One example is a rotary kiln, which gets equipped with a discharge system, afterburner, air pollution control system, and automated control system to move munitions forward and isolate feeds from propagating explosions, ensuring complete combustion of the energetic waste. Chemical destruction converts the explosive waste to benign or less toxic byproducts by changing the chemical composition of the energetics. One example is the industrial supercritical water oxidation method, which changes the chemical composition of the waste and destroys the energetics by subjecting the waste to temperatures and pressures above the critical point, utilizing water to break the energetics into gases, water, and sodium salts. The gases and water can then be recycled and reused. In general, disposal of energetic waste is illegal. Because the explosive hazards associated with energetic waste, the energetics must be destroyed and cannot be land disposed by burial, disposed by dumping underwater, placed into a solid waste stream, or disposed by other methods. The exception is unlit fireworks, which may be waterlogged and sealed in a bag for disposal. Illegal disposal of energetic waste is a federal crime. In conclusion, improper handling, transport, storage, treatment, and disposal of explosive waste has led to environmental contamination, death, and destruction. Explosive waste is regulated through various agencies and federal regulations to ensure human and environmental safety. While the current treatment method of OBOD does release pollutants directly into the environment and is a noise hazard, it is the safest method of explosive waste treatment in terms of mitigating unintentional detonation. OBOD can also treat a large amount of diverse waste in one pass, and this method does not require pretreatment. Alternative treatment technologies need to be better developed and understood to treat various explosive wastes as efficiently as OBOD, as these treatment technologies are safer for the environment. Though explosive hazardous waste will never fully be diminished due to the military using explosives in RDT&E, as well as wartime, with the military moving towards cyber and electronic warfare, the amount of explosive hazardous waste generated in the future will be greatly reduced. Here are references 1 through 9. Here are references 10 through 18. Thank you.